Alright, Algebra 1 fans, welcome to the notes for today. The topic is called dividing monomials. We've talked about multiplying monomials. When you multiply the variables, you add the exponents. So today, what's going to happen when we divide monomials? So audience, Algebra 1 objectives. After this lesson, students should be able to divide monomials using exponent rules. And this is actually the SOL standard A.2 Part A. Alright, before we start this here, let me tell you your algebra joke of the day. The question is, why is an algebra book always unhappy? And the answer is because it has lots of problems. Okay, so here we go. Section 1, divide monomials using expansion. So, as a warm-up, let's say we wanted to multiply all these fractions together. 1/2 times 2/3 times 3/4 times 4/5, so on, up until 9/10. Well, one way to do this, you could use a calculator. And you could do, when you multiply fractions, you multiply all the numerators. So you could do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And you're going to get an answer. You're going to get a big number. And then you could multiply the denominators and do that. And you're also going to get a big number. 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. So you get, let's see. So the top, the numerator is 362,880. And the denominator is 3,628,800. And then you would divide those two numbers and you would get an answer. Now, the thing is, there's a much easier way to do this. We don't even need the calculator. What we do need to do is understand a little bit about multiplying fractions. So, when you multiply fractions, again, you multiply the numerators together. And you multiply the denominators. But one thing you're allowed to do when this is multiplication, if you see a number in the numerator and you can reduce it with a number in the denominator, you are allowed to do that first before you multiply everything. So when I look at this, I see, wait a minute, this is 2 on top and 2 on the bottom. So this is like 2 divided by 2. Think of this as just one big numerator and then one big denominator. So this is just one fraction bar right here. And then these are all times. And so what we have here, what we can do is say, all right, 2 divided by 2 is just 1. That reduces to 1. 3 divided by 3 reduces to 1. 4 divided by 4 reduces to 1. Okay, all of these just become a 1 over a 1. 3 divided by 3, 1 over 1. So you can see the pattern here. The 5s divide, the 6s, the 7s, the 8s, and the 9s. So what does that leave you with? Well, in the numerator, all you have are a bunch of 1s that are multiplying each other. So we multiply them, and you get equals 1 over, what do you have in the denominator? Well, everything gets reduced except for the 10. So it's 1 over 10. That's your answer. Now this idea of reducing before you actually do the multiplying part, that's what we're doing today. So if you look at example 1, so now let's talk about variables. You have x to the 6th divided by x raised to the 2nd power, or x squared. Let's expand this. Just like we did when we started multiplying monomials, let's see what happens when you expand this. X to the 6th is x times x times x. 6 times we multiply it. 1, 2, 3, 4, 5, 6. Okay, over x squared, which is x times x. Now if you think of this like we did with this warm-up problem with all these fractions, before you do your multiplying, how about you make this thing simpler by reducing what you can? And when I look at this, I see, wait a minute, x divided by x is just 1. Whatever that number is, when you divide it by itself, you get 1. So what we'll write down here, I'm going to say x divided by x, I'm going to cross that out. Okay, that reduces to 1. And then we have another x divided by x. So in the denominator, all you have is 1. That's all that's left over. And in the numerator, well, we have 1 times 1, and then we have x times x times x times x. Now, let's put this back together here. Remember that when you multiply variables, you add the exponents. We keep the base, add the exponents. So that's x, 1 plus 1 plus 1 plus 1. We get x raised to the 4th power. That is the answer. Let's look at number 2. X to the 5th divided by x to the 3rd. X to the 5th, that's x times x times x times x times x. X to the 3rd is x times x times x. Well, let's do the same thing. Let's reduce. So we can take care of, and it doesn't matter which x's you cross out here. If I want to say x divided by x, that's just 1. 1. Anything divided by itself is always 1. So what do we have left here? Well, we have x times x, which is x to the 2nd. Now you could say, in your denominator, there's still something there. It's not 0. If everything gets reduced, then it's a 1. So it's x squared divided by 1, but we just write that as x squared. Anything divided by 1 is the same thing back. Okay, now number 3, let's do this one more time here. Let's expand. So we have x multiplied itself 4 times in the numerator, x to the 7th. We have to write this x down 7 times. Okay, there's 7. All right, let's reduce. X divided by x is 1. X divided by x, 1, 1, 1. Now this time, we've crossed out, we've reduced everything in the numerator. Now again, that doesn't mean there's 0 left there. It means it's 1. Because remember, we're dividing. Anything divided by itself equals 1, not 0. So our answer, we get 1 over, now what's left in the denominator, x times x times x, add up the exponents, you get x to the 3rd power. Okay, now we've done 3 examples of this. Obviously, we don't want to have to expand every single time we solve a problem. It would be nice if there was a shorter way to look at it. Well, let's go back to number 1 here. Look at the exponents that we started with. X to the 6th divided by x to the 2nd. What was the answer? X to the 4th. Look at number 2. The exponents were 5 and 3. What was the answer? X to the 2nd. Look at the 3rd example. The exponents were 4 and 7. What was the answer? 1 over x to the 3rd. So think about, how are we coming up with these exponents in the answer? And the answer is, we are subtracting exponents. We did 5 minus 3 is 2. We did, now 7 minus 4 is 3. We'll come back to this one because this is a little bit different because your bigger exponents in the denominator. And then we had 6 minus 2 is 4. Okay, so here's your rule. It says rule number 1 here, dividing monomials. If you take, now this is if you divide and you have the same variable. When you divide variables, what we do is we keep the base and we subtract the exponents. That's m minus n. So if you multiply monomials, you keep the base, you add the exponents. If we divide variables, you keep the base, you subtract the exponents. If you ever get confused, okay, if you ever get confused, try a simple example like number 1. Expand it and then ask yourself, how did I get this exponent 4? Oh, I had to subtract 6 minus 2. Okay, that's how you can look at this. So let's do some examples here. Simplify the following expressions. So this is number 4. We have e to the 8th divided by e to the 3rd, and then f to the 7th divided by f to the 4th. All right, what's the process? When you divide variables, keep the base, subtract the exponents. So that's e to the 8 minus 3, and then next to it we have f to the 7 minus 4. We get e to the 5th, f to the 3rd. Now, just like with multiplying, after you do this a few times, do you need to show the subtraction? Not necessarily, but it's a good idea to do so that you don't make mistakes. And a good example would be number 5 here. When you subtract this, we always take the top exponent minus the bottom. Doesn't matter which one is bigger. You get x to the 4 minus 6, and then y to the 3 minus 2. Now what happens here, we get x to the negative 2, and then y to the positive 1. Now there's a problem with this. This is not a simplified answer. We don't leave a negative exponent, or we don't write it as a negative exponent. Well, we had a rule. We talked about this last class. And actually, let's just go down to the bottom here for a moment, the bottom of your paper, because you have 2 new rules here. The first rule, anything raised to the 0 power is always equal to 1. Is always equal to 1. Now that may seem weird, okay, but let me give you an example for why this is going to work. If we take x to the 5th divided by x to the 5th, now would you agree that this value in the numerator, whatever x is, if you raise it to the 5th in the top, and you do the same thing in the bottom, these are the same value. Now if you take the same thing and divide it by itself, you have to get 1 for an answer. If I subtract the exponents, if I use my exponent rules, I get x to the 5 minus 5, which is x to the 0, but you know that when you take the same thing and you divide it by itself, you have to get 1. If you don't believe me, take a calculator. Take any number, 95, raise it to the 0 power. Okay, the way I did that, 95, here's my exponent button right down here, this little upward arrow. Enter. It's equal to 1. 106 raised to the 0 power, 1. 4 raised to the 0 power, 1. Okay, it's always going to give you 1 no matter what you do. All right, and then the second rule, and this is what goes back to our example number 5. If you have a base, raised to a negative exponent, then we write it as 1 over a to the positive exponent. 1 over a raised to the m power. Okay, so let's go back to number 5 here and finish this problem. If you have x to the negative 2, you can think of this as a fraction, as something divided by 1. If you have a negative exponent in the numerator, all we're going to do is we're going to bring it down to the denominator. And so what we get is y to the 1. That stays, because that exponent's positive 1. And then this becomes x to the positive 2. That's the answer. In number 6, when you divide variables, we subtract the exponents. So keep the base, subtract exponents. Now 13 minus 24, that's negative 11. So the answer is 1 over x to the positive 11. When you move it, when you take this and you move this variable and this exponent to the denominator, it becomes a positive exponent. All right, now let's look at something like number 7. All right, there's a lot of stuff going on here. Before you start dividing, you want to take care of parentheses, and you also want to simplify the top, and you want to simplify the bottom. So let's take the top here. xy squared z raised to the 3rd power. Now, let's put these exponents in here. These are 1s. When you raise a power to a power, remember from last lesson, you multiply the exponents. So you get x to the 3rd, 1 times 3. Y to the 2 times 3 is 6. And then z to the 3rd. Over. When you multiply variables, you add the exponents. So that becomes x to the 2 plus 4, which is 6. And then y to the 3 plus 8, which is 11. Now we can divide. When you divide variables, what do? You keep the base, subtract the exponents. So x to the 3 minus 6, y to the 6 minus 11, and then z to the third stays like it is. We get x to the negative 3, y to the negative 5, and then z to the third. When you have negative exponents, we're going to bring those down. So we get z to the third over x to the third, y to the fifth. And that's our answer.